Hi everyone. Today we will see Cambridge IGCSE Physics Paper 4 Theory Extended May-June 2023 Variant 2. First question. Figure 1.1 shows a helicopter which is stationary at a height of 1500 meter above the ground. State two conditions necessary for the helicopter to remain in equilibrium. Suppose the helicopter is in equilibrium means the force is upward force and the downward force that should be equal, and sum of all horizontal forces acting on the helicopter must be balanced. That means net force must be zero and there should not be any acceleration. Net force needs to be zero and no acceleration. So we can write the two conditions, that is no resultant force and there is no resultant moment. Next, the mass of the helicopter is 3,200 kilogram. Calculate the change in gravitational potential energy of the helicopter as it rises from the ground to 1,500 meter. So here gravitational potential. Change in gravitational potential can be written as mass into gravity into change in height. So here mass is given as 3,200 kilogram. Gravity is 9.8 and the change in height is 1,500 meter. Three thousand two hundred into 9.8 into 1,500. That is 4.7. We can write 1, 2, 3, 4, 5, 6, 7. So we can write it as 4.7 into 10 raised to 7 joules. Either it can be written as 47 into 10 raised to 6 joules. 10 raised to 6 means it is mega. So you can write the answer as 47 mega joules. Figure 1.2 shows a vertical speed time graph. Speed on y-axis and time on x-axis for a parachutist who jumps from a stationary hot air balloon. He jumps from the balloon at time t equals 0 and reaches the ground at B. Point A indicates when the parachute opens. So this is the point at which the parachute opens. So we need to label a point on the graph where acceleration is 0. So acceleration is 0. We can write it as 1, negative with 2 and decreasing with 3. So zero acceleration means the parachute reaches terminal velocity where the force of air resistance and gravity are balanced, resulting in no further acceleration. That is the point of constant acceleration or speed. So we can mark it here. Or here also he is having constant acceleration. So either this point or this can be marked as 1. Next is with negative acceleration. A negative acceleration happens when he slows down, and as a result, the opposing forces acting against the downward motion. It happens when the parachutist slows down as a result of opposing force acting against the downward motion. Here the speed is getting reduced. So we can mark it here as point 2, negative acceleration. And next 3, that is decreasing acceleration. So this 3 indicates that while he is still accelerating, the rate of acceleration is reducing over time. He is trying to accelerate, but it is reducing over time and has become a constant value. So before becoming this constant value, somewhere here we can mark it as point 3. That is decreasing acceleration. So acceleration 0, 1, it is here. Negative, it is here, 2. And 3, it is decreasing acceleration. The speed is not increasing. After this point, it starts decreasing. Next, explain in terms of force the changes in motion which occur from when the parachutist leaves the hot air balloon until point A. So when he is jumping from somewhere, starting the gravity will be high. The gravitational force will be high and air resistance will be 0. And as the speed increases, starting the speed will be more. As the speed increases, the air resistance also will start rising. And at some point, he will reach the terminal velocity. When he is reaching the terminal velocity means where the forces are balanced, then the net acceleration is 0. After that, he'll be traveling in a constant speed. Will travel in a constant speed. Here, the air resistance will be equal to weight or gravitational force. Air resistance will be equal to its weight or its gravitational force, we can tell. So at the moment he is leaving the balloon, he experiences significant gravitational force acting downwards. So the first point one point you can write it as there will be significant gravitational force in the starting. This gravitational force will be significant and air resistance will be 0. As gravitational force is significant, the speed increases. Speed will start increasing. So as the speed increases gradually or the acceleration is increasing gradually, the air resistance also will increases. And at some point, he reaches terminal velocity. So when he is reaching terminal velocity, all the forces are balanced. That is, net acceleration is 0. Net acceleration is 0. He is traveling in a constant speed. So here air resistance is equal to gravitational force. or we can tell weight. Next, a student catches a cricket ball. The speed of the ball immediately before it is caught is 18 meter per second. The mass of the cricket ball is 160 gram. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. So kinetic energy can be written as half mv square. Mass is given 160 gram. It can be converted to kilogram, that is 0.16 kilogram divided by 1000. 160 by 1000, that is 0.16. So half into 0.16 into V is 18 meter per second. V square, 18 square. 0.16 into 18 square divided by 2. That is 25. 25.9 joules. It can be approximate to 26 joules. Next, it takes 0.12 seconds to catch the ball and bring to rest. Calculate the average force exerted on the ball. So force can be written as F is equal to ma, and the equation for acceleration, it is velocity by time. So this point I am substituting here, that is m into v by t. So here m is 0.16 mass and velocity is 18 and time is given as 0.12. Mass, it was given mass as 160 gram, that is 0.16 kilogram, and speed of the ball is 18 meter per second and time is given as 0.12 second. So substitute it. 0.16 into 18 divided by 0.12. The answer is 24. So you can write the answer as 24 Newton. Next, as the student catches the ball, she moves her hands backwards. Explain the effect of this action on student's act. So here, moving the hand backward upon catching the ball allows for a gradual dissipation of force exerted by the ball. So when she's moving backwards, the dissipation of force will be less. There will be gradual dissipation of force. So here, longer the time of contact, smaller the force. The force acting on her hand will be less. There is less likely to get hurt. Next, figure 3.1 shows a person moving across an ice-covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. So he is lying down and he is moving. So we need to understand the concept of pressure. pressure is equal to force by area. So as area increases, pressure decreases. So when he is standing means the area of contact will be very less. As he is lying down like this, the area of contact is more. As the area of contact is more here, the pressure will be less. So we can write the answer as when he is lying down, the weight of the person is spread over much greater area. And as area increases, pressure decreases. Pressure will be low. And the ice is less likely to crack. Next, figure 3.2 shows a side view of a pond with a layer of ice floating freely on the water. The surface area of the pond is 5 meters square. Mass of the ice is 690 kg. Density of the water is 1000 kg per meter cube. A point X is being marked, that is 0.45 meter below the ice. Calculate the pressure at point X due to the ice and water. So we need to find the pressure due to ice and pressure due to water. So pressure due to water can be written as rho GH. Rho is the density of water, that is given as 1000 kilogram per meter cube, and G is gravity, that is 9.8, and height is given as 0.45 m. This will multiply. The answer is 4410. This much Pascal is the answer. So next we will find the pressure due to ice. So weight is given here. So under the equation, pressure can be written as force by area or weight by area. So force is mass into, here it is gravity, mass into acceleration by area. So mass is given as 690 kilogram into gravity is 9.8 by area is given as surface area of the pond is 5 meter cube. 5. So 690 into 9.8 divided by 5. That is 1352.4. 1352.4. Now we need to find the total pressure. So total pressure means it is pressure due to water plus pressure due to ice. 4410 plus 1352.4. 4410 plus 1352.4. So you'll be getting the answer 5762.4. 5762.4 Pascal. It can be rounded off and written as 5.8 into 3 points I am taking, that is 10 raised to 3 Pascal. So this is the total pressure. Next, the temperature of a fixed mass of gas at constant volume is decreased. State and explain in terms of particles how the pressure of the gas changes. We know ideal gas law, that is PV is a constant, that is pressure into volume is constant. PV is equal to nRT. That is, if the volume is constant, the number of gas particles remains the same and the pressure is directly depending on the temperature. If temperature increases, pressure also will increase. And temperature decreases means pressure also will decrease. Here temperature decreases. So as temperature is decreasing, the particles within the gas slows down. That means their average kinetic energy decreases. So as the average kinetic energy is less, the particle moment also it is less. The particle moment reduces, it decreases. So collision will be less. As particle moments are less, collision also got reduced. So collision is less means automatically pressure will reduce. So here pressure is getting reduced as the slower moving particles. All the particles are moving in a slower motion. So this slower moving particle has less momentum. And they collide with the walls with lesser force. Collide with the container walls with lesser force. Next, state the value of absolute zero in degree. That is minus 273 degrees Celsius. Explain what is meant by term absolute zero. Refer to particles in your answer. So absolute zero refers to the lowest theoretically attainable temperature where the thermal motion of particle within the substance theoretically ceases. That means at this temperature, particles would possess least possible kinetic energy. So kinetic energy of the particles. Kinetic energy will be very less at absolute zero. It is the lowest theoretically attainable temperature where the thermal motion of particles within a substance theoretically ceases entirely. So at this temperature, particles would possess least amount of kinetic energy. That is the main point. Kinetic energy will be least at absolute zero. Next, cylinder 1 contains 350 centimeter cube of gas at pressure 9 into 10 raised to 4 Pascal. So we are having two cylinders. So in one cylinder, 350 centimeter cube of gas at pressure 9 into 10 raised to 4 Pascal is there. The gas is being transferred to another cylinder. And here the pressure is 1.6 into 10 raised to 5 Pascal. The pressure has been increased. The temperature remains constant. We need to find the volume of cylinder. So ideal gas law, we know PV, it is a constant. That is product of pressure and volume is constant. So we can write it as P1 V1. That is for cylinder 1, pressure into volume will be equal to P2 V2. We need to find the volume of cylinder 2. So V2 can be written as P1 V1 by P2. So P1 is given as 9 into 10 raised to 4 and V1 is 350 and P2 is 1.6 into 10 raised to 5. 9 into 350 divided by 1.6. That is 1968.75 into 10 raised to 4 and this will go on the top, that is minus 5. So 10 raised to 4 minus 5, that will be equal to 10 raised to minus 1. So we can shift 1 point here, 196.87 and it can be approximate to 197 or rounding to significant figures, that is 200 centimeter cube. Next, figure 5.1 shows a electric heater used to heat a room. The dimensions of the room, it is given as 4.5 meter into 6.1 meter into 2.4 meter. The density of air is 1.2 kilogram per meter cube. Show that the mass of air in the room is 79 kg. Density can be written as mass by volume. From this, mass is equal to density into volume. Here, density is given as 1.2 kilogram per meter cube into mass is and volume is 4.5 meter into 6.1 meter into 2.4 meter. So meter into meter into meter, it will write it as meter cube. One 1.2 into 4.5 into 6.1 into 2.4. That is equal to 79. This meter cube and this meter cube will get cancelled. The answer is 79 kilogram. So hence it is proven. The power of the heater is 1100 watt. The specific heat capacity is 1000 joules per kilogram degree Celsius. Calculate the time taken to increase the temperature of the air in the room from 16 degree to 20 degree. So we need to calculate the time here. So there is one equation, that is energy is equal to power into time. So time can be written as energy by power. So here we need to find the energy. So energy is mass into specific heat capacity into change in temperature. So here mass is given as 79. We have found out from the previous thing, that is mass is 79 kg into specific heat capacity is 1000 and change in temperature, that is 20 minus 16, that is 4. So 79 into 1000 into 4 will give the energy 79 into 1000 into 4. That is 316. As I am taking here 79, I will be putting 316000 joules. So substitute the same value here. That is 316000 by power is 1100. So just this answer I am taking, this answer divided by that is 287.47. 287.47 seconds. You can round it off to 290 seconds. So just one reason why the time calculated in A2 is the minimum time needed to increase the temperature of air in the room from 16 degrees Celsius to 20 degrees Celsius. Here energy is power into time. Time can be written as energy by power. Power is a constant, is given as 1100 and energy we have calculated. So here the energy was around 316,000 joules and power is also given. So as this power output remains constant, the time required to transfer a specific amount of energy is also fixed. And here the thermal energy is being transferred to objects in the room. Here the power output is constant. So the time required also it will be constant. To transfer this specific amount of energy. Here the thermal energy is transferred to object in the room. Figure 5.2 shows a cross-section of double glazed window in the room. So outer glass pane is shown, narrow air gap is there, inner glass pane is shown. State the main methods of thermal energy transfer from the room to outside, which are reduced by this type of window. Mainly there are three types of heat transfer. That is conduction, convection, and radiation. Radiation is through electromagnetic waves, transfer of heat through electromagnetic waves. Convection means it can be through liquid, gases, or air. Contact through air, liquid, or gas. And conduction means it is through direct contact of materials, or you can tell through solids. So as it is a double glazed bento, it reduces the heat transfer. And here the heat transfer mainly occurs only through conduction and convection, through contact of this glass pane and through this air inside this narrow gap. So answer is conduction and convection. Here, the presence of multiple glass panes separated by a narrow air gap act as an effective barrier against these modes of heat transfer. The conduction through the materials and convection by air movement are both limited due to this design of window, thereby reducing the amount of heat that can pass through the window between the interior and exterior spaces. Next, Two types of seismic waves are P waves and S waves. State the type of wave that P waves and S waves can be modeled as. So this is actually example for P wave and this is an example for this is S wave. P waves and S wave, that is primary waves. P means primary. S means it is secondary waves or shear waves. These are seismic waves that travel through the earth after earthquake. So these two types of wave occur after earthquake. So P waves, it is compressional type wave that propagate through solids, liquids, and gases. They cause particle to vibrate in the same direction as the wave movement. So P waves are considered as longitudinal waves due to their compression nature. Due to the compression nature and the particles vibrate in the same direction as the wave movement. In the same direction as wave movement. And in the case of S waves, they're shear waves or secondary waves that propagates only in solids. This will propagate only in solids and this can be modeled as transverse waves. Because, because of the perpendicular moment of particles to the direction of wave travel. Here the particles move perpendicular to the direction of wave travel. Next, the velocity of P wave in Earth's salt crust is 7.2 km per second and its frequency is 4.5 hertz. Calculate the wavelength of this P wave. So V can be written as F lambda. Lambda is the wavelength. We need to calculate the lambda, that is the wavelength. Lambda is equal to V by F. So V is given as velocity, that is 7.2 km per second. And F is given as 4.5 hertz. So 7.2 divided by 4.5. That is 1.6. That is equal to 1.6 kilometer. If you're converting to meter in 2000, that is 1600 meter. Next, figure 7.1 shows a container of oil. So oil is there in the container. A ray of light shines on the surface of the oil. The refractive index of the oil is 1.7. On figure 7.1, draw the normal at the point where the ray enters the oil. So we need to draw the normal. That means it is perpendicular to this plane. So we will draw a perpendicular line. So this is the normal. So we have drawn the normal line. And this will be the angle of incidence I. The angle X is 56. So this angle is given as 56 degree. Calculate the value of angle of refraction. So sin I by sin R, that is I means angle of incidence and R means angle of refraction, that is equal to N2 by N1. N2 means it is the refractive index of second medium, that is oil. So we know the refractive index of oil is 1.47 and N1 means refractive index of the first medium, that is air, that is 1. So sin I by sin R is equal to 1.47. We need to find the angle of refraction. So rearranging this equation, sin R is equal to sin I by 1.47. So what is I here? So totally it is, here it is perpendicular, that is 90 degree. So I will be equal to, angle I will be equal to 90 minus 56. That is 34. So I is 34. So sin 34 by 1.47. So sin of 34 will take, that is 0.559 by 1.47. Sin 34 is 0.559 by 1.47. So this answer divided by 1.47, that is equal to 0.380. So sin R is equal to 0.38. Next, we need to find the value of R. So it will be equal to sine inverse of 0.38. So sine inverse of this answer, that is 22.3. So R is equal to 22 degree. So we have found the angle of refraction as 22. State the approximate speed of light in air. Speed of light in air, that is 3 into 10 raised to 8 meter per second. Calculate the speed of light in the oil. Give your answers to 3 significant figures. Here, speed of light in a medium. Here it is oil. That will be equal to speed of light in vacuum or air by refractive index of the medium. So speed of light in air is 3 into 10 raised to 8 by refractive index in medium, that is in oil, it is 1.47. 3 divided by 1.47, that is 2.04. 2.04 into 10 raised to 8 meter per second. That is the speed of light in oil. Next, state what is meant by magnetic field. Actually, magnetic field is a region in space where magnetic forces are present. Suppose you are having one magnet, you could be having north-south poles, some field will be there. Some magnetic force will be around this magnet. That region is called as magnetic field. A magnetic field is a region in space where magnetic forces are present. Due to the presence of magnets or magnetic materials or moving electric charge. Define the direction of magnetic field. The direction of magnetic field is the direction of north magnetic pole that would be oriented if placed at a particular point in the field. That is, it is the direction of force on the north pole. Simply we can tell it as the direction of magnetic field will be in the direction of the force on the north pole. It is the direction in which a hypothetical north magnetic pole would experience a force if placed at that point. The figure shows a negatively charged metal sphere. Draw 4 lines to show the electric field and its direction. So it is negatively charged. So 4 lines equally spaced will draw. One at this point, here, here. 4 straight lines we can draw it. As it is negatively charged, the arrows will be inwards. If it was positively charged, the arrows would have been outwards. For example, the sphere is this one and is positively charged means we will draw the arrows outwards. As it is negatively, the arrow should be inwards. Next, the figure 8.2 shows a circuit. So we can see a circuit here. The 3 cells are identical and have 0 resistance. So here 3 cells it is given. 1, 2, 3. They're identical and they are having 0 resistance. Resistance R1, R2, R3 are identical. So we can conclude that R1 is equal to R2 is equal to R3. That can be written as R. The reading on the voltmeter is 6 volt. So the total voltage it is 6 volt. As it is identical cells, so drop across each cell will be same. When the diode is conducting, it has zero resistance and zero potential difference. That means the diode is ideal. Determine the EMF of one cell. So for finding the EMF of one cell, the total voltage is 6 volt. So we can do it by 6 by 3. Total 3 cells are there. That is 2 volt. As it is identical cell, each cell will be having 2 volt. Determine the ratio of potential difference across R2 to potential difference across R3. So we need to find the potential difference across R3, that is VR3, and the potential difference across R2, that is V2. So we are assuming here actually the diode is in the conducting state. Diode is forward biased or conducting means in this diode, this is your anode region and this is the cathode region. So anode is connected to positive and cathode is connected to negative. This is forward biased condition. And your diode will be on condition. If the connection is just reverse, that means anode is connected to negative and cathode is connected to positive. This is actually reverse bias condition. In this case, diode will be in off position. So here the switch is in closed position. Diode is on. This R1 and R2 are coming in parallel. R1 parallel R2. So when two resistors it is coming in parallel, we need to find the equivalent resistance. R1 parallel R2. So the drop across these two resistance will be same. So we will find the equivalent resistance as R1 and R2 are equal. R equivalent can be written as, when it is in parallel, R1 R2 by R1 plus R2. This is the equation. And we can substitute. Actually, R1 and R2 is R. So R into R by R plus R, that is 2R. So this R and R will be getting cancelled. You can write it as R by 2. So R equivalent is equal to R by 2. So here we need to find the ratio V2 by V3. That is potential difference across R2 by potential difference across R3. So V2 by Ohm's law, you can write it as I2 R2 and V3 can be written as I3 R3. So here diode is closed. I'll just change that equivalent circuit. We can just draw the equivalent circuit as 3 cells will be there. This is your R3 resistance. These two are in parallel. We have found out the equivalent resistance. That is R by 2. And this is actually R. So this is a series circuit, right? The circuit is series. So the current flowing in this series circuit will be always same. That means I3, current flowing through I3 will be equal to I2. Same current, that is equal to I. Same current will be flowing in the circuit. So you can cancel this one. I and I will be getting cancelled. Instead of R2, this is actually R by 2. And R3 is R. So this R and R will be getting cancelled. We'll be getting 1 by 2. That is ratio of V2 is to V3. Potential difference across V2 to V3 will be equal to 1 is to 2. This will be the answer. State and explain the change in current in R1 if all the cells are reversed. So now the condition is we are reversing all the cells. That means here negative, positive, negative, positive, negative, positive. R3 is there. Here R1 is there. Here diode was there, right? But diode will be in off position. Because before we are told diode negative, it is connected to positive. Here diode negative is connected to positive. Means diode is in off position. This circuit, this point, it will be open. And here R2 is there. So this section will not come to picture. This is open now. So again, we can minimize the circuit. That is, it doesn't consist R1. It consists only R3 and R2. As diode is not conducting, as we are reversed all the cells, here R3 will be there. Here R2 will be there. So this portion diode is not conducting. The circuit will be like this, R3, R2. And the current flow will be always from positive to negative. Current will always flow from positive to negative. In this path, it will be flowing. There is a change in current in this way. And through R1, through R1, there will not be any current as your diode is not conducting. This path will be open and the current through R1 will be 0. There is no current through R1. Determine the new value of ratio of potential difference across R2 to potential difference across R3. So here potential difference across, that is R2 is V2 and potential difference across R3 is V3. We know R2 is equal to R3 is equal to R. Identical resistance. R1 is not coming to picture here. So V2 by V3, current is same. And V2 by V3 will be equal to I R. First this I will write V2 R2 by I3 R3. Both I it is same. I2 I3 will be same. As it is series circuit, I2 equal to I3 equal to I. And R2 is equal to R. I3 is equal to I and R3 is also equal to R. So it is 1 by 1. So the answer is V3. V2 is to V3 can be written as 1 is to 1. So the ratio of potential difference is 1 is to 1. Next. Table 9.1 shows some properties and values for alpha particles and beta particles and gamma radiations. Complete the table. The type of radiation, number of protons, number of neutrons, charge, stop by. So alpha it is 2 and number of neutrons it is 2. Charge is given. In the case of beta particles, number of protons it is 0. Charges it is just like negative, that is minus 1.6 into 10 raised to minus 9. stopped by thin sheet of aluminum. Gamma particles, number of protons 0, number of neutrons 0, charge is also not there. It is stopped by a very thick concrete. State how beta decay changes the nucleus of an atom. In case of beta decay, the neutron is converted to one proton plus one beta particle that can be negative or positive plus one anti-neutrino or neutrino. So here the nucleus has one less neutron and one more proton. This neutron is count is being reduced as it is converted to proton, and proton count will be increased. The nucleus has one less neutron and one more proton. Next, a radiation detector used in a laboratory detects a background count rate of 30 counts per minute. A radioactive source is placed in front of the radiation detector. The initial reading on the detector is 550 counts per minute. The half-life is given as 25 minutes. Calculate the expected reading on the detector after 75 minutes. So, initial reading it is 550. So, first we will find the initial count. The reading shown it is 550 and the initial count due to the source will be 550 minus the background count rate that is 30. 550 minus 30 that is 520. And we need to find the final count at NT that can be written as initial amount into 1 by 2 raised to T by T. So initial amount it is 520 into 1 by 2 raised to T, small t, that is the current time. We need to find that is 75 minutes and half-life. Capital T is your half-life, that is 25 minutes. So 2 raised to 75 by 25 will be getting 520 into 1 by 2 raised to 75 by 25 is 3. 2 raised to 3 means it is 8. So we can write it as 520 by 8. So 520 by 8 it is 65. So this is the final count. Next we will find the final reading that is shown. So final reading can be found by adding the final count plus background count rate that was 30. So 65 plus 30 is already given. So that is 95. 95 counts per minute. State 2 safety precautions taken when moving or using or storing radioactive sources in a laboratory. So it needs to be shielded or it needs to be stored in lead boxes. And we need to avoid direct contact with radioactive sources. State the equation that defines the average orbital speed v of a planet. State the meaning of any symbols you use. So average speed can be written as v is equal to 2 pi r by t. Here, r is the average radius of an orbit. And capital T is the orbital period. Pi is 3.14 and 2 is the average orbital speed. Suggest why countries that are significant distance from the equator experience significant temperature variation throughout the year. So if you are considering Earth, there will be tilt of 23.5 degree. So due to this tilt in the Earth's axis, the rays from the sun strike the country at different angles throughout the year because of the tilt. That's why we are experiencing different temperature variation. That is rays from sun strike the country at different angles throughout the year. This happens because of Earth tilt. Fill the gaps in the paragraph about a star much more massive than the sun. The stage follows the stable state in the life cycle of a star. Is the red super giant stage. The stage that follows the stable state in the life cycle of a star is the red supergiant stage. It then explodes as a supernova to form a nebula. This leaves behind a neutron star or a black hole. Black hole or a white dwarf. A galaxy is moving away from the Earth with a speed of 33,000 km per second. The value of Hubble constant is 2.2 into 10 raised to minus 18 per second. Calculate the distance from the galaxy to the Earth. Give your answers in light year. So Hubble's constant h0 is equal to v by d. We need to find the distance d. So d is equal to v by h0, that is v is given as 33,000 kilometer per second by h0 is 2.2 into 10 raised to minus 18 per second. Can be written as into kilometer, that is 10 raised to 3 by 2.2 into 10 raised to minus 18. $33,000 divided by 2.2, that is 15,000 into 10 raised to 3. 10 raised to minus 18 will go to numerator, that is plus 18. That is 15,000 into 10 raised to 21. So we have found the distance in meter and we need to find the light year. So we need to convert the distance from this kilometer to 1 light year is equal to 9.46 into 10 raised to 15 meters. So distance in light 10,000 into 10 raised to 21 by 9.46 into 10 raised to 15. $50,000 divided by 9.46. That is 1,585. 1,585.6 into 10 raised to 21 minus 15. That can be written as 1,585.6 into 10 raised to 6. So these three positions after changing, that is 1.58 can be written as 1.6 into 3 plus 6, that is 10 raised to 9. So the distance is 1.6 into 10 raised to 9 light years. Thank you.